Hello everyone, this is Dr. Abdul Pasha, Assistant Professor, Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering College, Hyderabad. So our course is Power System Operation and Control. In this, we are going to discuss the topic called Mathematical Modeling of Governor Mechanism. Earlier video, I explained you regarding the governor mechanism, what are the various blocks, what is the purpose introduced for governor mechanism, how speed can be controlled, what parameters we are going to consider governor mechanism, block diagram details. These are the aspects covered. So for the same case, we are going to derive mathematical modelings for governor. So here in mathematical model of governor mechanism, we are going to consider some basics of speed governing mechanisms and their modeling analysis. So speed governing is the main primary tool for the load frequency control. So whether the machine issued along the feed line to a smaller system or whether it is a part of the most elaborate arrangement. So we developed a model in the manner of schematic arrangement. So the main features of that particular mechanism of speed governing system that may be used on steam turbines. So this is introduced to control the output of the generator. So this will maintains the constant frequency that we can see in here. So here its major blocks or components are represented. So this is the model view of the model governing mechanism. So it contains various blocks, speed changer block, steam inflow into the line, and this is one of speed governor. Pilot valve is allocated here, which is situated with high pressure oil. Hydraulic amplifier is provided on the bottom case. Main piston is ready to move across the line. So these are the major blocks we can see into this modeling of governor mechanism. So what happens here means in this system, initially the flow that should be introduced from the steam is going to make into the chamber. This will fluctuate in this chamber. According to that, the piston movement will take place up and down. So with this, we can generate or release more pressure. We can generate or release more pressure into the system. So now that the speed governing mechanism can develop more force according to the piston movement. Here we can make direction of positive movement along the direction of Y. So here are some of the speed changer locations which will start from I1, I2, I3, I4. So these positions may got interchanged their locations from A to B, B to C, C to D, T to. So these are the positions we developed for making the speed changer concern. So here we will introduce one of the other speed governor mechanism that is called by the name flyball speed governor. So what is this flyball speed governor? So usually this is the heart of the system which senses the changes in the speed. So as the speed increases, the flyballs moves outwards and the point B on linkage mechanism is going to move downwards. So the reserve is going to happen when the speed is going to be decreases. So with this, we may consider one of the device or block called hydraulic amplifier. So what is the functionality of this hydraulic amplifier that we will see now? So basically it comprises a pilot valve and a main piston arrangement. So with this pilot valve and piston arrangement, we can adjust the low power level pilot valve movement, which is going to be converted into high power level piston valve movement. So this is necessary in order to open or close the steam valve against high pressure. So this can be helpful to move or close the steam valve against the high pressure conditions. We have another block called linkage mechanism. What we can observe with this linkage mechanism means, with this linkage mechanism, we can connect more number of components. That is, for example, ABC is a rigid link pivoted at a B and CDE to the another rigid link which is pivoted at D. This link mechanism provides a movement to the control valve in proportion to the changes in the speed case. So it also provides a feedback path from the steam valve movement that is considered with the basics of speed governing mechanism and modeling analysis. We have another more block called speed changer. What is the speed changer? It provides a steady state power output setting for the turbine. It provides a steady state power output setting for the turbine. It downwards the movement opens the upper pilot valve so that more steam is admitted to the turbine case. So under these steady state conditions, that means more steady power output is going to be generated. So the reserve thing is happens for upward movement of the speed changer case. So here we will make a simple analysis as in the manner of brief explanation of the diagram like this. Steam enters into the turbine through a pipe that is partially obstructed by a steam admission valve. So in steady state, the opening valve is determined by the position of a device which is called the speed changer. So that is upper left corner, that is shown in the figure 1. This is shown in the upper left corner. This one, upper left corner. This is allocated with the steam valve here. So with this upper left arm, we can make the device with the speed changer. We can adjust or fix the positions of the steam valve through the two rigid rods. So what are the names of the rigid rods means? A, B, C and C, D, E. These are called two rigid rods. A, B, C and C, D, E. So A, B, C is one of the rigid rod. A, B, C. And C, D, E arrangement is another rigid rod. So with this rod arrangement, the reference valve or set point of the turbine power in steady state is called the reference power. Reference power. So when the load on the bus is suddenly changes, the shaft speed is going to be modified. And a device which is called to control the speed of the system is named by speed regulator, which acts through the rigid rods to move the steam valve. So that are going to be located as a similar effect which could be produced by temporarily modifying the reference power. That means we justifies the name as speed changer. So in practice, both control schemes used are simultaneously. So amplifying the number of stages, generally hydraulic in nature, which are introduced to magnify the output of the controller case. And it is ready to produce the forces which are necessary to act and to move the steam valve inwards. So modeling of the speed governor, in this analysis, we are going to develop the mathematical case based on some small deviations around a nominal steady state. So what are those means? We should assume that the steam is operating under steady state and is delivering power P naught G from the generator at nominal speed or frequency. That is about F naught. So under this condition, the prime mover valve has a constant setting that is called X naught E. So the pilot valve is here closed and the linkage mechanism is supposed to be stationary. So now we will increase the turbine power by delta Pc with the help of the speed changer. So for this movement, the movement of linkage point A moves downward by a small distance called delta into A. So it is going to be represented by one of the condition, and the linking point C will move upward. This is because of linkage mechanism from the rod A to B, B to C position in action. So let it be further, the link point D moves the piston in pilot servo with V. The resulting will be in higher pressure oil flow in the upper part. So that is connected to the main piston. So the piston moves downward by an amount delta XD and the steam valve opening is going to be increases. So it increases the torque developed by the turbine. Thus it will increases the torque of the particular machine. So this torque is now going to increases the speed of the generator, that is based on the frequency changer levels as delta F. So this change of speed is going to result in the outward movement of the fly ball. So this will be taken with the speed regulator. So thus the link B moves slightly downward to a small distance delta B. So due to the movement of the link point B, the link point C also moves downwards. This is the ratio of delta XC, which is also to be proportional to the delta F case. So thus the net movement of the link point is C is going to be connected. So here we will develop some mathematical analysis with the considered assumptions, as delta XC is considered for the mathematical modeling, which may be the combination of delta XC dash plus delta XC double dash. This is one consideration as 2. So in the equation 1 manner, we will consider the parameters as in the manner of delta XB. So as if you consider the negative sign, as in the flow is in the reverse aspect, then delta XC dash IAB is equals to delta XA into IBC. So similar case, if you consider for C, the negative sign will reflect as minus delta XC is equals to delta XA IBC by IAB. This is going to be considered with equation 3. So we know that from the equation 1, the delta XA becomes one of the constant Kc into delta Pc, which is going to substituting in the equation 1. Then K1 is IBC and IAB. So delta XC dash is equals to minus sign with Kc delta Pc into K1. So delta XC dash equals to minus K1 Kc delta Pc. This is represented with equation 4. And delta XC double dash can be represented with one of the constant K2 with delta F, where delta F is going to be considered the change in frequency level. And this coefficient may also represent that the change in frequency level is considered with the delta XC double dash as K2 delta F. So thus the net movement of C is considered as delta XC equals to minus K1 Kc delta Pc plus K2 delta F. So this is the equation 5 consideration. So the movement of this D with the delta xd is the amount by which the pilot valve are going to be opens. So it is contributed by delta xc and delta xc, and it can be written as delta xd equals to delta xd dash plus delta xd double dash. This is equation 6. So delta xd dash is ICD plus IDE, which is equals to delta xc into IDE. So delta xd dash equals to ICD plus IDE by IDE into delta xc. This can be written as equation 7. So now delta xd dash as k3 delta xc, which is equation 8. This is equation 8 actually. So delta xd double dash as in the manner of ICD plus IDE gives delta xc ICD. So here delta xd double dash gives ICD plus IDE by ICD with the aspect of delta xc. So this delta xd double dash in terms of the product K4 will be the factor of delta xe. So this product is equivalent to delta xd double dash. So thus we can represent that delta xd equals to K3 delta xc plus K4 delta xc. This is written as equation 9. So now if you make the assumption made that the flow of oil into the servo motor is proportional to the position of delta xd of the pilot valve V, then the movement of delta xe of the piston can be represented easily. So this can be done here. Now with the certain assumption, it is made that the flow of oil into the servo motor is proportional to the position delta xd. So this is connected to the pilot valve V. Then the movement of delta xe of the piston can be represented as delta xe equals to delta xv k phi, as it may be the variable of minus delta xd dt with equation 10. This is going to be considered, and taking into the Laplace transformation of the respective equations 5, 9 and 10, then delta xc of s equals to ns k1 kc delta pc of s plus delta f of s. This is equation 11. Now making this delta xd of s minus k3 delta xc of s plus k4 delta xc of s, which is equation 12. Now delta xc of s minus k phi of 1 by s delta xd of s gives equation 13. So eliminating delta xc of s and delta xd of s, then delta xc of s into 1 plus k4 k phi by s is equal to minus k phi ks by s minus k1 kc pc of s plus k2 delta f of s. So delta xc of s minus k phi k3 k1 k naught of delta pc of s minus k2 by k3 kc of delta f naught. So if you simplify these parameters as a delta xc of s minus k2 k1 kc by k4, then change in frequency levels can be obtained here. This gives one of the constant generator k2 k1 kc by k4, where the generator constant tg as 1 by k4 k5 with 1 by r as k2 k1 kc. So the value of this tg is less than 100 milliseconds, means the equation can be written in terms of the factor delta xc of s minus delta pc of s minus 1 by k delta f of s into kg by 1 plus nt. This is equation 4. So the model of the speed governor mechanism is shown with the control blocks as a delta pc of s, which is connected to one of the control blocks given to 1 by r ratio as delta f of s. So this kg by 1 plus stg is connected to delta xc of s or delta pb of s. So these are some of the references which I have taken to make the system parameters derivation. So this analysis of the frequency considered to be mostly accurate results with the system changing parameters in terms of its delta. So when the delta is going to be changes, then the parameters are going to be less, which can be reflected to show the frequency control operation with respect to the system constraints. So these constraints will make the system smooth working operation of the speed governor mechanism. As the speed goes on changes in the valve from the force levels according to the diagram shown here, the turbine can ready to generate that will be connected to the generator will give more power. So according to the opening and closing of the valve contacts, the main piston is ready to give the more force with respect to the steam content. So likewise, the system is ready to operate to the extent levels. So this can be achieved with the speed changer mechanisms from lower and upper arms of the raising water levels. So according to that, the piston can ready to move in the suitable ranges for water inflow at the extent of levels. So this will make the mathematical modeling of the governor in terms of its speed changer with frequency at rated levels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.